subnormal series for 9.6 for S3, right? Is this your question?
Yes.
I did this in class, right? In the notes? No? You can find another. This is actually just nothing, but if you want one more, right? Because this is a subgroup which is normal. Okay, so this is just a trivial one. You normally don't want to see this, but this is a subnormal series, which is also a normal series. Done? Okay, because the index is 2, right? This is H, right? So so the index is 2, so it's normal. Okay, so H is normal. You understand that, Tan?
Can be having 1, 2, or 2, 3, or
Okay,
1, 3.
if you put 1, 2, this is not normal.
Oh.
That is the previous chapter, right? Chapter 8. This is not normal. There are ways to show it's not normal. You can find the coset. Okay, there will be the order. Okay, the order is 3. You will have 3 coset, so you can check the left coset and the right coset. They are not equal. So that is one way to show they are not normal. Or you can use normal. So G inverse HG is it in H, right? For all G in S3. So you can also show, this is easier. You don't have to list all 3 left, list all 3 right, because it's not normal. So you just take 1G multiplied by 1, 2, multiplied by G inverse and show it is not in 1, 2. Okay, that is the easiest. So it is not normal. So any subgroup of order 2 is not normal for S3. Only this is normal in S3. Right? Done? Is it clear? Okay?
Okay.
Okay, any other question?
Prof, may I know how to do question number 4?
Yeah, Lava?
Question number 4.
Question number 4. Okay. Z42. This is the group, yeah? Now, okay, let me see this. This is your integer, right? Okay. And let me show you one easy one first before we do this one. What is this?
Negative 2, 0, 2.
Right? Right? 2, 4, 6, and so on. Negative 2, negative 4, and so on. So what are the coset? Okay, this is the factor group, right? So last time we read it like this, right? So G, now the whole thing is called G, but this is H. Okay, it's like people coming up the stairs or knocking at the door. Okay, so this is another example. Let me show this first because there are not many coset. So this is our H, right? This is a different example. Okay, now this is one coset. So then you cancel, right? Right? Because they are all in here. This is what we do. But there's only just one left. So when you take like one of the coset, right? This is H. Then 1 plus H, what is it? Add 1, right? Okay, so these are all, right? Because now, when we cancel, everything is cancelled. Okay, so for this particular question, you only have H and 1 plus H, right? And this is isomorphic to Z2. Because you have only 2 elements. Okay, this you can map to 0. This you can map to 1 in Z2. Isomorphism. So there are 2 of them. Now you want to do the same thing for this. Okay. Any question before I erase this? Is this clear? Where is your thumb? Okay, Ahmad? Ahmad, is it Ahmad? If it's clear, show your thumb. So like, not only me, you have to find where is that reaction down there. Okay, yeah? Because I want to erase to make sure you understand. You have any question? Just unmute and then just stop. It's okay. If you don't understand, just stop. Okay, I erase, yeah? This is clear. Okay, so you can imagine if this like 3, right? 3, then you will have 3, right? Coset, because it's 3, 6, 9. So 4, you will have 4. Okay, so now we will look at 42. So 0, 42, and then 42, and then 42, 84, right? 126, and so on. Negative 42, negative 84, and so on. Okay, so this is 42. So if you cancel, you will cancel like from 0 until 42. So you see, you will have Again, 1 plus H, 2 plus H, until 41 plus H. How many? How many? Cosec?
42.
42. Okay. So, Z mod 42 is isomorphic to Z 42. There are 42 of them, the cosec. Okay. And the question is, find all composition series of this. Because this is a billion. Okay, that's a billion. Okay, and you look at the composition series. A composition series is a finite sequence of subgroups. Okay, let me write that. H dot H1 Hn of G such that, so this one I can do Z for. Such that Hi is a subgroup of Hi plus 1 and Hi is a maximal normal subgroup of Hi plus 1 with H naught is E and Hn is G. Okay. So this is like subnormal, right? Because we have, this is just a subgroup, but this is a different one. If you don't have this is just subnormal, right? If you don't have this is just subnormal. But now it's a maximal normal. What does it mean? Okay, so this is in the notes, so I erase, yeah? Hi is maximal normal in Hi plus 1 if Hi is normal in Hi plus 1 and there is no K such that Hi is in K and K is normal in this. So you have this. You want this to be normal. Okay, maximal normal means not only this is normal, you cannot find any K in here in which K is also normal. Okay, cannot have. If you have this K, this is the maximal normal. Okay, if there is no in between. Right? Understand, Lava? Almost understand. Okay. You want to see an example, right? So I give you one example, yeah? You have Z8. Okay, Z8. You have this, right? The subgroup. Right? It's a subgroup, right? Okay. Is this a maximal normal subgroup in Z8? Lava, because you are the one that asked me this question. You unmute. Okay. Is this normal? That is the first question. Is it normal? It's normal because it's a billion. Yeah? This is easy example. Okay, so I ask again, is it normal?
Yes.
Okay. Is it maximal normal? Tan said no. Why?
Two,
Because,
denominator two.
because there is something inside that you can put. There's a subgroup. And they're all normal because it's a billion. Okay? So if you think about this subgroup lattice, okay, the maximal normal has to be the one on top, right? If you remember, that's why I choose this. Right? If you remember the subgroup lattice, so this is the maximal. No, but this is a billion, so all normal. We don't have to check. Okay. So this is the maximal normal. All right. Okay, now this is easy because this is a P group. Right? It's a P group. The question is not a P group, it's a composition in the order. So let me give you another example. Z. I give you this before, right? Okay. 2 squared cube, right? So you have 2, you have 3, then you have 4, then you have 6, then you have 1. Sometimes they draw it differently. I think, how do they draw it? I think that goes, right? Yeah, I think a book. Yeah. Okay, this one because they want it like a square here, nice. Okay. It's a good thing to call. WhatsApp call. Because Tinan went out, and I think also Hannah, if you share, look at your notes, maybe you didn't see.
Yeah.
It's a good thing to, or call WhatsApp call, group call, right? Everyone will get the call. If you realize your friend is not in the class, you have to let me know, the others. Because the only way I can hear it if you unmute and you talk in there. That is because my phone is sometimes even chat I didn't see. Okay? Okay, so this is the maximal subgroup, normal, right? In this case, it's all a billion. But we have another one maximal. So you can have two maximal subgroups. Okay, Lana, I don't want to give you the answer straight away. I want you to think because of this. So you will have two composition series. One is, right? Lava? Yes? Okay? And another one is, right? So both are composition series. Okay? Okay, equivalent means equivalent series. What is the definition? I didn't put inside. Do I put the definition inside? Equivalent is like you can map like this. Okay, the length, they are also the same length. Right, the length, they are also the same, and you can map like this. Okay, that's equivalent series. But you can try and Google and find the definition for this one. Okay, so this is this case. All right, you can see. Now, change this to 42. This is the question, right? Remember, our original group is a factor group. This is not equal. Okay, so the answer is isomorphic to the original one, right? The original one, all in terms of factor group. But you can say somehow that it is isomorphic to this. So the original one is something in the form of H, right? The element in the factor group. You see? The element in the factor group is H, 1 plus H until 42 plus H. So this is the one isomorphic to Z42. So the original one is in the form of this, isomorphic to this. And the subgroup is also like when you say this is this of order 21, 2, 4, and so on. In here, the 0 is here, the 2 is 2 plus H, right? 0, 2, 4, until 40, right? Right, 21. This is isomorphic to H, 2 plus H, 4 plus H, until 40 plus H. So my point is, the original question is in the form of cosets, but I want to talk about just the isomorphism. Okay, so somehow in your answer, you can mention that this is isomorphic image of the original question. Otherwise, you need to put like this. Instead of 2, you will put also okay. And this one is equal. Okay, now my point is 42 is 2 times 3 times 7, right? As product of primes. Okay? So think about the subgroup lattice. Okay? Try to draw subgroup lattice. Try to think about this is a billion group. So every factor dividing this has a subgroup. So what are factors of 42? Because you are the one that asked me this question, Lava. You unmute first. Okay. Read the factors.
142.
Wait. Go up, increasing.
1,
1, 2,
3,
3,
6,
6,
7,
7,
21,
14.
21.
Before 21, you don't have 14.
Oh yes, 14, 21, then 14.
You know how I get it? 1, okay, 1, 2, 3, 6, 7, 14, 21, and 42. Yep. Okay. So if you have 42 here, you have 3, right? So you break up into 3 because they are not connected to another, they are primes. So that will be 2, 3, 7, right? So this is order 21. This is order 14. This is order 6. Now I'm going back to chapter what? Chapter 3, cyclic group. Now the next subgroup is the one with this order. Okay, so you have 1, 2, 3, 7, right? Now 6 is contain this one, right? And 7 is contain this one. But you also have 14, right? Combination. And then 42 is, okay? So what are your composition series? Lava, how many? How many different composition series?
I don't know that.
Just now, I had 2 composition series. Right? Just now. I had 2 composition series because we have prime 2 and 3. Now we have how many composition series? 3. Because this is the maximal subgroup. This is the maximal normal subgroup. So your composition series will be 0, 2, and this, right? Or 0, 3, this. Or 0. Now I give you the answer. I don't want to give you the answer. I want to give you just the hints. Now I give you the answer. It's Lava's fault. So now, because this is the maximal normal, okay? This is the maximal normal. If you want to add in, because the maximal normal, okay? Let me say it again. The maximal normal, if you have the series, one is in the maximal or the other one. So what happens if you put like this? Is this okay? This is maximal in here, right? This is maximal in the next one. There is nothing in between. If you put this and this, if you put this and this and this, this is wrong. Okay? Because this is not maximal in here. This is maximal in here is okay, but this is not maximal in here. So the composition series will be, you can do this.
I think we have 6 composition series proof.
This 1,
Hmm?
2, 3,
Yes. Hmm.
and then
0, 21. Hmm.
1,
Hmm.
2,
Hmm.
3,
Yes.
4.
4. And we have 0, 21, 3.
This.
Yeah.
Just now there are 3, right?
Yes.
3 equivalent 1. Now
Hmm.
1,
Hmm.
2,
Hmm.
3,
3,
4,
4,
5,
5.
6.
Yes.
Try it. Okay. So the equivalent one. So the equivalent one with the 3 length and the equivalent with the 4 length.
Yes.
Right, right? The 4 length. 1, 2, 3, 4, 5. Because this one you cannot really see, right? Because okay. Baba? Okay. I don't want to write list, then I give you all this. But I think it's a good hint, right? You can get the idea. Okay, all right, good. Okay, I think that's the question for chapter 9, right? Okay.